Hello everyone, a very good afternoon and welcome to Byju's Exam Prep. So in the morning session, we had covered many important topics. We completed the discussion on floods, we covered droughts, and we covered tropical cyclones as well. Now, in the second part of today's session, let us focus on other disasters like cloudbursts, heat waves and cold waves, GLOF events or glacial lake outburst floods, and the others which are still left. So let's begin with cloudbursts. Let's finish all the meteorological hazards and then let's continue with the remaining disasters. Cloudburst is a topic which is frequently in news. UPSC has already asked few questions on cloudbursts in the previous exams. So this topic remains very relevant, very important for your prelims and also for your mains. Not just from disaster management point of view, but even in geography and environment ecology, cloudburst can become an important topic. Because India faces many floods and flash floods as a result of cloudburst incidents. Recently, for example, just a couple of months ago, in Himachal Pradesh and also in Uttarakhand, we witnessed devastating flash floods. I'm sure you would have seen this in news. You would have seen the visuals, the damage that had been caused, right? There were multiple rounds of flash floods that affected Uttarakhand and Himachal Pradesh. These flash floods were attributed to possible cloudburst events in the Himalayan ranges. So, as a result, the topic becomes very important for the coming exam as well. So, let's understand what is a cloudburst. Let's understand how cloudbursts occur, what is its immediate impact, and how can we deal with them from a disaster management point of view. This is actually a smaller topic compared to cyclones and droughts, but nevertheless, it is still an important topic. So let's quickly study what is cloudburst. The name cloudburst is inspired by bursting of a water balloon because usually there is a analogy between clouds and water balloons, right? Just like a water balloon is delicate, which is holding a lot of water. The moment you prick it with a pin or with a sharp edge, the balloon will burst, releasing all the water in one go. So usually there is an analogy drawn here. That's where the term cloud burst comes from, right? It's believed that the cloud itself is bursting, releasing large volumes of water in a small place. But the phenomena is not like that. It's not that the cloud is exploding or bursting. All right. By looking at the name, don't think the cloud is bursting open and releasing all the water. That's not the phenomena involved. There is a different mechanism, a different process that is involved here. There is a physical geographical process, a meteorological process that is responsible for a cloud burst event. Is that clear? So, a cloud burst is essentially a period of very intense rainfall. It's not very different from your regular rainfall. All right. It is just rainfall which is happening. But the difference is that there is a very, very large amount of precipitation. A very large amount of precipitation that is occurring in a small area in a very short period of time. This event is what is classified as a cloud burst event. In a very small given area, usually in hilly areas, cloudbursts occur in hilly ranges. It does not occur in plains. Is that clear? There are certain characteristics associated with cloudburst. They are present only in hilly mountainous areas. In these regions, when there is heavy amount of rainfall received in a small area in a short amount of time, such an event is classified as a cloudburst. Several days and weeks of rainfall is received within 1 hour. The amount of water which pours down, that amount of rainfall occurs over many months, sometimes over a year. That huge volume of water is dumped in just few minutes, in just few hours, that too in a very small area. So this sudden outburst of water which starts flowing down the slope, right, is what is referred to as a cloudburst event. All right, so let's see how does this occur. You can see this point here. Cloudbursts will dump large volumes of water in a small area in a very short period of time. Such intense, extremely heavy rainfall is called a cloudburst event. This occurs because in the mountainous region, in the hilly mountainous region, the rain bearing clouds and the winds associated with it, they undergo something known as orographic lift. You would have studied this basic concept in geography, even in your school days. Whenever the terrain is rising upwards in hilly mountainous areas, the wind, which also carries the moisture along with it, will also start rising along the surface of the slope. This lift of the wind along the terrain, along the slope of the mountain, is called orographic lift. This happens on the windward side of the mountain, where the wind is approaching and striking the slope of the mountain. So, as these moisture bearing winds rise upwards, it will condense quickly to form very dense clouds. And when it interacts with the cool parcel of air present at the top, this warm, moist air will suddenly precipitate. It results in a violent reaction, and there is sudden precipitation that will occur because of this mixing, this sudden interaction between warm, moist air that's rising up, which comes in contact with the cold parcel of air present at the top of the mountain. It is this which causes the sudden precipitation and brings massive volumes of rainfall in this small area. Is that clear? I'll repeat this point. Cloudburst is often seen in hilly mountainous regions. This is where moisture laden winds, which is carrying warm moisture, approaches the mountain from the windward side. Then it undergoes orographic lift. The wind with the moisture starts moving upwards along the slope of the mountain. So, as the moisture laden wind currents, which is now condensing to form clouds, as it comes in contact with the cold air parcel at the top, it results in sudden precipitation. This sudden violent precipitation causes extreme amount of rainfall to be received in this small region, that too in a matter of minutes or in just few hours. The volume of water received will be so high that this amount of rainfall is usually received over many months, sometimes over an entire year. Imagine that volume of water being dumped in just few minutes, just few hours, that too in a very small place. So obviously there is a rapid flow of water. The surface runoff will be rapid and it will be massive. So all this water which precipitated, right, it will start gushing down the slope. This massive volume of water will flow with great velocity, unimaginable velocity, and comes crashing down the slope of the mountain. So as a result, it can trigger very intense flash floods. It can weaken the structure of the slope itself. The topsoil will become saturated with water. The structural integrity of the slope can be compromised, and the slope can slip under the influence of gravity, causing devastating landslides. This is how a cloud burst, which is a hazard, becomes a disaster. It triggers these cascading events, these connected events like a domino effect, like a chain reaction. The intense heavy rainfall received, right, in this slope area, in this mountainous area, will cause massive flooding in the low lying areas, along with the possibility of massive landslides. So, this is what causes loss of life. It leads to death and injuries. The human habitations that are present along the slope and in the downstream, they will be washed out, they'll be completely wiped away by the waters which is flooding the region. The landslide will bring all the soil material, debris, rock, and vegetation crashing into the slope, into the valley, causing widespread devastation. So, any infrastructure that could be present in the downstream, that will be wiped out. Roads, bridges, railway lines, they'll all be wiped out by the floods and the landslides. Houses, buildings, infrastructure, they'll all suffer enormous damage, leading to a lot of deaths and injuries. The environment also suffers damage due to destruction of the vegetation, pollution of the rivers in the downstream, right? There is ecological impact as well. And that is the reason why cloudbursts are dangerous events. It's a major hazard that leads to floods, flash floods, and landslides. Is that clear? Now, in today's world, we have to pay more attention to cloudbursts because it is a type of extreme weather event. Just like cyclone, heavy rainfall that causes your regular floods, just like that, cloudburst is also an extreme weather event. It's a meteorological phenomena. It's a weather related phenomena, and these phenomena are becoming more extreme. You're witnessing more such incidents, meaning the frequency of these cloudburst events has gone up. The intensity also has become more severe. You're witnessing very severe cloudburst events more regularly. And this is believed to be a result of global warming and climate change. So, as the global average temperatures continue to rise due to man made climate change, we are likely to witness more such extreme weather events, which includes cloudbursts as well. So, that is why areas like the Himalayan region becomes more vulnerable. Places like Himachal Pradesh, Uttarakhand, Sikkim, Arunachal Pradesh, right? Some parts of Western Ghats as well. Few parts of Western Ghats. Then even Nepal, Bhutan, and some other locations around the world. They're all vulnerable to such events where there is extreme rainfall received due to this phenomena that takes place in the mountainous regions. Now, how do you differentiate a cloudburst from regular rainfall? How do you identify that this situation you're facing, this flood situation you're facing, is a result of regular heavy rainfall or is it a cloudburst? There should be some differentiating factor. To make this differentiation, the IMD has a criteria. Again, IMD is the nodal agency because this is a meteorological phenomena. It's a weather-based phenomena. So, India Meteorological Department is the nodal agency to track these events and provide early warning and forecasting. All right. So, it has identified a criteria that any rainfall in excess of 10 centimeters per hour in a given small area will get classified as a cloudburst event. But however, there is some criticism here. Some experts believe that most government agencies are misinterpreting heavy rainfall as cloudburst events. The media, especially, it labels any heavy rainfall as a cloudburst, right? So there is some confusion regarding this, that there is no clear criteria to define how cloudburst occurs and when you can declare a cloudburst event. So more studies would be needed, more research would be needed to specifically identify these criteria and to better understand the phenomena behind this process. So right now, if a small region gets more than 10 centimeters of rainfall in 1 hour, right? Then that event is classified as a cloud burst. That is 100 mm of rainfall. This is massive. It is honestly massive. 100 mm of rainfall is received over several months. Imagine that volume of water being poured in just few minutes or in just 1 hour in a small area. Imagine what will happen. The carrying capacity of the water channels, the drainage system gets overwhelmed, naturally causing these intense flash floods and landslides. Is that clear? So the impact is very evident. It's very, very clear. It causes intense flash floods leading to loss of life, death, and injuries, triggers very severe landslides at multiple locations, and causes significant damage to infrastructure. You guys might have seen recent images from Uttarakhand where flash floods happened, right? There was a railway bridge which was floating in the air. It was a very widely circulated image on social media and also in newspapers and television, right? It means the bridge was being suspended, the railway track was suspended in the air. It means the whole soil material below was washed out. In the Himalayan slope in Uttarakhand, the flood was so intense that the entire soil material in the slope has been removed. It's been pushed down, causing a landslide, and the railway track is hanging in the air. That is the impact, right? So that is the impact on your infrastructure. Now, let's say there are power plants, hydropower plants located in the downstream. Let's say important government facilities are located, or entire villages and towns are located in the downstream. They will face the devastating impact of these floods and landslides. That is why the death count can be very high. The number of people who get injured, who go missing, who drown can become very high because the response time here is very, very less. You get a very short response time. Yesterday, when we discussed regular floods caused by heavy rainfall, I told you that you get some advance notice. Heavy rainfall can be anticipated few days before. Water levels in the rivers and dams can be monitored regularly. So even before regular floods can happen, there is some advance warning. But in the case of cloudburst and flash floods, it becomes very difficult to provide early warning and to send the alert. By the time you realize what's happening and send the alert, by that time the disaster would have already happened. So the response time here is very short, very, very limited. So this is where we have to improve our technology with regard to early warning and forecasting. Technically, it is possible to predict cloudbursts. The technical resources are there. The technical skills, the know-how is already present. It's just like tracking rainfall, right? Just like you track any meteorological phenomena and rainfall, you just have to do the same here. But the challenge, the real challenge is that can you provide localized forecasting? This is the challenge for any forecasting agency with regard to cloudburst. See, right now, IMD, which tracks rainfall and provides alerts few days before, it is able to provide you alerts for big regions, for large areas, like for an entire state or one district, for the whole country. Such broad estimates can be provided because that is the kind of tools we have right now. By using satellite data and by using Doppler radars, rain gauges, you can provide broad estimates for a bigger region, like an entire state or one part of the state or one district. Now, how do you deal with a cloud burst which is happening in one slope, in one mountainous area? It could be happening in just one small village in one district. So you can do this. Technically, it's possible. You need more Doppler radars. You need Doppler radars at the local level to track the clouds, right? That is when you can provide the forecasting. But this will be very difficult to achieve. Practically, it's very difficult because that will require a lot of investments. You need a lot of resources, and you need advanced supercomputing facilities as well to crunch the data and forecast these events. So technically it is possible. Solutions are there. Problem is in implementing, in scaling it up. So what we can do, we can prioritize some regions through our risk analysis, through our studies and assessments, and previous experience, previous historical data. We know that there are specific areas in Uttarakhand, specific areas in Kerala, some areas in Northeast, some areas in Himachal Pradesh, which are prone to cloudbursts, which are prone to flash floods. Maybe we can prioritize those regions only and improve our forecasting methods by installing more Doppler radars. The IMD is already doing this. It will take some years, but IMD is already initiating those efforts to provide localized forecasting, at least in these places where heavy rainfall and flash floods are common during the monsoons. Understood? These floods and landslides, they will pollute the river as well. They'll bring a lot of sediments and silt, because all the soil which is getting washed off, it will enter the rivers. The river will get polluted. You might have seen the very color of the river will turn. It will turn orange or almost reddish orange. That is the amount of soil material which has mixed. So all the sediments and silt, it will sit at the bottom, which will block the flow of the river as well. It will affect the carrying capacity. So this could create future problems. Next time when even regular rainfall is received in the area, the carrying capacity is affected due to these blockages and silt deposition, and even that could increase the possibility of flooding. There will be devastation to our ecology, right? Flora and fauna will take the full impact. Biodiversity loss will be guaranteed, and this will turn into long-term socio-economic loss. Tourism will be disrupted, right? If tourists are caught and if they lose their lives, and if these incidents occur in tourist locations, definitely tourism will take a hit. Agriculture will take a hit. If the agricultural land is repeatedly hit by these incidents, agriculture takes a hit. Any other economic activity which is present in the area will take a massive hit. Your infrastructure, especially power plants, roads, railway lines, bridges, power grids, and your internet mobile connections, they'll all be uprooted, causing enormous destruction in the affected area. Is that clear? So what happens after a cloudburst is exactly like floods and landslides. It's the same phenomena. So just understand what is a cloudburst and how does these events occur. How do we classify a cloudburst event? So if you understand this, it's more than enough. All right. Now, how do you deal with this hazard? What can you do from disaster management point of view? Obviously, start with risk analysis. Identify the areas which are prone, and you have to be very specific here. You can't just say that Uttarakhand is prone. That's not enough. For classes, it is enough. For academic purposes, it is enough. But those who are involved in disaster management, like IMD, NDMA, the state government of Uttarakhand, the Ministry of Home Affairs, right? They have to get very specific. Not just the district, not just villages. They have to specifically identify which regions have the possibility of being affected by cloudbursts. That localized data has to be generated. Based on that, try to install early warning forecasting systems. Provide for localized forecasting, as we were discussing. Ensure you put in place more Doppler radars at the local level. And along with your satellite data, right, and other data which is received from various inputs, provide for localized forecasts. Track the clouds in these areas and see which of them has the potential to burst and cause these events. Then every other step is the same as floods and landslides. There's nothing different. Whatever we studied for floods, the same measures will apply. The same structural measures, non-structural measures, like arresting the surface flow, right? Breaking the velocity of the water through afforestation. diverting the flood water by building embankments, culverts, canals to ensure that the flood water is dissipated. Then creating barriers, retention walls, which can protect the communities from landslide and floods. Non-structural measures like land use planning or zoning, so you can restrict and regulate human settlements, construction, and human activities in the most disaster prone areas. Regulate tourism. Don't allow exploitative over tourism to happen. Don't allow resorts and towns and hotels to come up in these high risk areas. The local people, right? Even their activities have to be restricted. Identify the flood prone areas, landslide prone areas, and restrict or prohibit agriculture and other economic activities. Regulate construction. So, all these measures which we discussed under floods have to be taken up along with protecting and conserving your natural buffers. Is that clear? Protecting the forests, promoting afforestation, tackling deforestation, protecting the water bodies, protecting all the wetlands, lakes, and rivers, tackling environmental damage. So, once you take care of these measures, you will focus on response and relief to search and rescue people, to provide basic immediate assistance, then to rehabilitate them and ensure that you reconstruct the damages and help recover that region back to normalcy. So this will require a lot of coordination, a lot of planning, a lot of preparedness, right? It requires awareness generation as well. You have to spread awareness amongst the locals, amongst the tourists. They should be aware of the risks. They should know what to do, what not to do when landslides and flash floods occur or when heavy rainfalls are reported. All the authorities, state level authorities, district authorities, and all concerned government agencies, they should be trained, their capacity should be built, there should be enough mock exercises as well, mock drills. So, all these steps have to be taken up as part of disaster management. Is that clear? Now, please take a look at this map over here. This shows the hazard map, the hazard vulnerability map with regard to cloudbursts. So, these parts of the Himalayan mountains from Kashmir towards Himachal Pradesh, Uttarakhand, this region is very prone. Some parts of Sikkim, some parts of northeast India, Western Ghats as well, all right, and few parts near Mount Abu. Essentially, mountainous areas, the possibility of a cloudburst exists. All right. So, if you can understand this phenomena and how we can mitigate the impact through disaster management, this is more than enough. All right. The questions you are going to get here will be straightforward, very simple, straightforward questions. And whatever we have covered, every single point is equally important. Now, let's move on to the next topic. Let's take up landslides and avalanches. Landslides and avalanches, because landslide especially is linked with floods. It's also related to other factors, but landslides do have a direct connection with floods. So let's study this hazard and understand how it becomes a major disaster. Be it landslide or be it an avalanche, the phenomena is the same. The process involved is exactly the same. Avalanches occur in snow-capped mountains. In snow-capped mountains, avalanches occur, whereas landslides, or also called landslips, they occur in hilly mountainous area. In the hilly regions, in the mountainous region, this is where your landslides, landslips can occur. But the process and the phenomena is more or less the same. The factors are also pretty much the same, right? That's why we have to study them together. Now, how do you define a landslide or an avalanche? How do you explain what is a landslide? See, this is something we have been discussing from yesterday itself. I explained the connection between floods and landslides. Right? We have been mentioning this again and again. We mentioned this under cyclones as well, cloudbursts as well. So by now, I think you have a fair idea what is a landslide. A landslide is essentially a sudden slippage, a sudden movement of the soil, debris, rock, and vegetation present on the slope, which will crash into the valley under the influence of gravity. Now imagine this to be a mountainous slope. On the slope, there will be a lot of soil, rocks, and other debris that is present. There will be vegetation as well, some tree cover. Now, all of this can slip in one sudden movement. There could be one sudden downward slippage where all of this could come crashing down into the valley below. Right? This happens under the influence of gravity. When the structure of the slope is weakened, if the slope loses its structural integrity due to some factors, then gravity will act. It will pull down, and this entire material will come crashing down into the valley. This sudden movement of rock, soil, debris, vegetation, and any material present on the slope, that is called as a landslide. If the same phenomena occurs in a snow-capped mountain, where the snow and ice, the entire snow sheets, ice sheets will slip and crash, we call that as an avalanche. All right? So this is essentially a type of mass wasting. The mass of the earth is getting wasted. It's getting pulled down. It's being pushed down, causing this sudden large slippage, which causes the disaster. The direct influence of gravity pulls down all the material on the slope if the slope's structural integrity has been compromised. Now the question is, what factors can cause this event? What factors can lead to the weakening of the structural integrity of the slope? Right? It can't happen on its own. There should be some other causative factor. There should be some trigger. So there are some natural factors. There are some man-made factors as well. Or it could be a combination of the two. So these factors can trigger a landslide or an avalanche. All right, let's see which are these factors. Heavy rainfall, as we have studied already. Heavy rainfall received in a hilly area causing floods where the water is flowing down at a very high speed with great velocity. It could saturate the topsoil with water. That soil becomes weak, it becomes clayey. The soil loses its structural integrity. And especially if the slope has suffered from deforestation, right? Because see, vegetation, the presence of plants, trees, it's very crucial for the slope's integrity. Because the roots, they are giving structural integrity. They are holding the soil together, the slope together. We humans, what we do? We destroy everything. We cut down the forests for tourism, for agriculture, for large projects, for industrialization, for urbanization. So when we do this, when we destroy the vegetation like this, the slope will become weaker. The soil becomes weaker. And when water flows down with great velocity during heavy rainfall or even during cloud burst, right? The soil which is saturated with water becomes vulnerable for movement, downward movement. So it means the integrity is compromised, the structural integrity. So gravity will do the rest. Gravity will pull down everything and it crashes in one sudden movement, which is basically a type of mass wasting. Correct? Similarly, an earthquake, uh, even a medium-sized earthquake, earthquake of medium magnitude, around 5 or 6 magnitude, or devastating earthquakes of 8, 9 magnitude, they introduce tremors. They introduce the shaking of the surface and the slopes. So this also weakens the integrity of the slope and you can witness a landslide or a avalanche. So all these are natural factors. Heavy rainfall, floods, then cloudburst, earthquakes. All these are natural factors. Coming to man-made factors. construction, explosions, mining. These are the primary causes. In mountainous areas, mining activities might be taken up, and that requires controlled explosions. Or even for constructing roads, railway lines, hydropower plants, explosions are set off to clear the way to build these projects, right? And even the movement of heavy vehicles in these mountainous areas, when roads are built, when railway lines are built, the movement of the vehicles, heavy vehicles, also introduces tremors and causes shaking of the slope. So, over a period of time, this could weaken the integrity of the slope. And when there is rainfall or when there is an earthquake, everything will slip and crash, causing a landslide. So, man made factors, if not directly responsible, they are definitely aggravating the risk. Along with the natural factors, it will cause the disaster. Understood? Now, please look at this image. Focus on this image here. You can see a snow avalanche being depicted over here in a snow capped mountainous area. The snow and ice sheets have slipped and crashed. This can happen naturally as well. When a lot of snow is getting accumulated, right? The slope may not be able to hold it. The structural integrity will, will be compromised and the ice and snow can crash down. Or if it is triggered by human activities like trekking, skiing, there are incidents where skiers have triggered avalanches. It's possible. One small breakage in the ice sheets that have accumulated can slip the whole snow and ice material, causing a massive slipping of this entire snow and ice material. So we call this a snow avalanche. Next, debris avalanche. It's exactly the same, but what is crashing down is different. Instead of snow, it is the vegetation, the soil, rocks, and debris. You can see how the mountain slope has become denuded. It's completely exposed. See, this is the actual mountain. Now look at what has happened here. This entire area, this entire slope has slipped. So all the soil, rocks, debris, vegetation that was present, everything has crashed into the valley. Now imagine if people are present here. Imagine if there are any infrastructure projects present over here, right? Everything will be crushed. People will be trapped, they'll be killed immediately. This is what causes the large scale destruction. Another type of landslip is a rock avalanche, where only rocky material slips, only rocky debris will slip and crash, causing a disaster in the downstream. So, this happens frequently in India as well: snow avalanche, debris avalanche, and even rock avalanche. All right, the names are different depending on what is crashing down, but the process, the phenomena is exactly the same. So, they are triggered by natural factors like heavy rains, floods, cloudbursts, earthquakes, and the risk is aggravated by man-made factors like construction, constant movement of heavy vehicles, explosions and blasting, mining. All these activities can weaken the slope and cause a crash of the mass material. So please make a list of the causes. You can even get a basic prelims question. UPSC might ask you to identify the causes for a landslide. It might give you some options, right? So please make a list of all the causes that I have mentioned. Even volcanic eruptions in active volcanic zones can cause a landslide. Like, for example, in Indonesia, Indonesia is a very active volcanic zone. There are multiple active volcanoes. When there is a volcanic eruption, right, the hot lava magma that flows down the mountain slope can also weaken the slope and cause a landslip, right? So, landslides are associated with volcanoes as well. apart from earthquakes and other natural phenomena. Even the regular weathering and erosion, the physical chemical weathering which keeps happening in nature, in the environment, could also weaken the slope. So, along with all these natural factors, if there is some man made factor which is giving that trigger, then these landslips will occur. All right. So, they will happen not just in the interior regions of the landmass, they can happen in coastal areas as well. In the coastal areas, there might be hilly mountainous cliffs. There are many places in the world where you have hilly mountainous cliffs right on the coastline, like UK, Scotland, Australia, US, even India also has few places where such hilly mountainous cliffs are present. So constant erosion by the sea, the constant striking of the sea waves against the cliff could also weaken the integrity. This is natural again. It's a natural process of weathering, right? This could also cause a landslip directly into the sea, into the water body. All right. So please make a note of all the factors. I've listed them over here, including the man-made factors. So from deforestation to rampant agriculture, unsustainable agriculture, large-scale construction, vibrations from machinery, traffic, blasting and mining, large-scale earthwork where a lot of earth material is removed, cleared for big projects, urbanization, right? In Uttarakhand, look at the pilgrimage towns. Because of over exploitation of tourism, entire settlements have come up on dangerous slopes. Hundreds of houses are built, hotels are built, and this is over exploitation. That's why the Himalayan ecology is so sensitive. It's very delicate. First of all, the Himalayan belt is naturally sensitive because of the active seismic zone that is. It's a very active tectonic zone. So earthquakes are very common, right? The slopes are very weak. They're not very mature. It's not a very stable slope. In such hazardous area, we have increased our population. We have brought more people, carried out a lot of construction and activities, which is leading to more of these disasters. Got it? So let me give you some important data regarding India's vulnerability. Let's identify the exact regions in India which are prone to landslides and avalanches and understand what extent of area is vulnerable. Around 12.6%, 0.42 million square kilometers of our land area, leaving the snow covered region. This amount of our land area is prone to landslides. You leave the avalanche areas, you leave out the higher Himalayan ranges, right, from Kashmir to Arunachal Pradesh, you leave out the snow capped areas where avalanches happen, then in 12.6% of our land area, landslides are frequently occurring. All right. So this includes the northeast region, you have hilly mountainous areas which are extension of the Himalayan mountains, right? From Arunachal to Nagaland, Manipur, Mizoram. You have a north-south range that runs here. In Meghalaya, near the Bangladesh border, you have the Garo Kasi Jaintia hills. Even Assam has many hilly mountainous terrains. So all across this region, heavy rainfall, floods, and earthquakes, accompanied with human activity, can trigger landslides. Most of the landslide prone area is located in the northeast, which includes the mountains of Darjeeling and Sikkim. All right, this is one of the high risk areas, followed by Uttarakhand, Himachal, Kashmir belt. All right, this entire region here. Next, the Western Ghats from Kerala and Tamil Nadu all the way till Karnataka, Goa, and Maharashtra. Because Western Ghats does receive a lot of rainfall, during the monsoons, right? And in the Western Ghats, there is a lot of human exploitation, from deforestation to mining to excessive tourism to large projects. All the threats are present. So Kerala is very prone. Parts of Tamil Nadu in the Nilgiri ranges is very vulnerable. All across Karnataka, that is wherever Western Ghats are present, from Belgaum to Shimoga all the way till Madikeri, Coorg. Then Goa and Maharashtra, from Pune, Mahabaleshwar, that whole belt, the Konkan ranges. This whole region is prone to landslides. Just recently, just few months back during monsoons, there was a devastating landslide in the Konkan range where railway tracks were destroyed. Many people were killed because of this devastating landslide incident. All right. Then finally, there's one more region you can see over here. Can you see the small dot in Andhra Pradesh? This is part of Eastern Ghats. In the Eastern Ghats, there is a small area called the Araku Valley. Very, very popular valley. Do you know why is it popular? Or do you know where exactly it is located? Can you tell me in the comments? Let's see how well aware are you with regard to India's geography. Araku Valley is popular for some reason and it's present very close to an important location. Any idea? Yes, it is in Andhra Pradesh. I told you that. But can you tell me the exact place where it is located? Vivek has given the right answer. Ragini. Araku coffee is very popular. It's known for coffee plantations. All right. And where is it located? Chituri and Deepesh have given the right answer. It's near Vizag, Vishakhapatnam. Right next to Vishakhapatnam, it's a coastal city. On the outskirts, you have Araku Valley, these mountain ranges of Eastern Ghats. All right, it's a very beautiful location. So the British, they turned this into a hill station because of the cooler climate. And they promoted plantation crops, especially coffee cultivation. Araku coffee has a distinct flavor. Right now, it's being branded and promoted around the world. All right, it tastes very good. If you haven't tried, please do. Araku coffee has a very distinct flavor compared to the coffee that comes from Karnataka, right? So this part of Andhra Pradesh also witnesses landslides during rainy season. So this is the vulnerability of India. Now, these points I've given, they are very important for prelims. You can get a prelims question. UPSC can give you the names of few places and it might ask you to select which of them can witness landslides. So this knowledge that I've given you will help you in answering that question. Is that clear? You just have to apply some common sense. Those questions will become very easy to answer. Now coming to the last part. How do we deal with landslides? What can we do with regard to disaster management? First step is always risk analysis. You have to study the disaster, understand your hazard, understand the vulnerability, the exposure. So based on that, you compute the disaster risk. This is the first basic step in any disaster management, right? Understand the hazard profile, the vulnerability profile of your country, which exact regions, which areas are prone, and understand what is their exposure. Right? Based on this, figure out the disaster risk and accordingly start acting. Put in place early warning systems. Yes, it is possible to give some early warning in case of landslides. It's possible. Technically, it is possible. But the challenge again, just like cloudburst, is in implementing it. The technology is there, the tools are there. But problem is in providing localized alerts. Landslide will not happen across the entire state of Uttarakhand. Landslide will not happen across entire Western Ghats. Correct? So that information is useless for early warning. Early warning has to be very specific. We have to find out which slope might slip, which mountain specifically might slip. This requires lot of localized data. It requires intense geological studies. You have to study the slopes, the integrity of the slope. You have to monitor the integrity of the slope regularly, right? Along with that, you have to study and monitor the meteorological factors like rain, the floods and cloudbursts which contribute to it. Keep a check on earthquakes. So all of this has to be integrated into one system. So it's very, very challenging to provide that localized alert. But India is working on it. We have started a project. Please write this down. The National Landslide Susceptibility Geo Database for India. It's a mapping program that's been launched by the government of India, the National Landslide Susceptibility Mapping Program. Under this program, by using various technological tools, including GIS data that is generated from satellites, and we are clubbing it with geological data that is procured through geological studies, ground level studies, which is done by the Geological Survey of India, right? And there are a few other institutions as well which are involved. So we are using this data to create a landslide map of the country at a very minute scale, at a scale of 1 is to 50,000. This will give the localized picture. We are prioritizing the prone areas. Not We don't have to do this across the country. Like landslides will not happen in Madhya Pradesh. It will not happen in Bihar. You don't have to waste your efforts. Focus on Himachal Pradesh, J&K and Ladakh, Uttarakhand, Western Ghats, Araku Valley, and Northeast India. That is what India has been doing. It's been preparing an inventory, a database by using GIS data. Right? GIS data is generated through your satellites. It is geospecific information. It is tagged to the location. Satellite studies will help in understanding the slope, the distribution of the slopes, the integrity of the slopes. Along with that, you conduct your ground studies, right? Through geological studies, you present more data to understand the integrity of the slope. And based on that, you create a network of sensors which gives you real time data and use that to provide real time alerts. So, this is a very complicated system. It's a very complicated task, but India is making an effort. Through this mapping program, we are trying to understand the susceptible areas. And in the future, maybe it will take 10, 20 years, maybe more than that. But the plan is to put in place a early warning system. All right, at least where the risk is high. Next, you prepare. Take up your planning and preparedness steps. First step is regulate human activities through your zoning standards, land use planning. Restrict agriculture, restrict construction activities, restrict explosions, mining, and large projects. If projects have to be taken up in public interest, certain precautionary measures have to be taken. Today, engineering is so advanced, civil engineering. You can strengthen the slope, you can reinforce the slope with engineering solutions. Let's say a road has to be built for connectivity or even for security reasons, because these are border areas as well. So our security forces like army, they have to move the troops and equipment. They need strategic border roads. Let's say railway lines have to be built, power plants have to be built, right? You can't stop them. Those are needed for the nation's growth. So what we can do is we can regulate that construction. We can lay down the standards, and through engineering solutions, you can strengthen the slope to ensure it doesn't slip during a landslide event. Is that clear? So this can be done, but it requires very strict enforcement of these zoning standards and building construction standards. Basic measures like afforestation. Protect your plants, your trees, your forests. protect the vegetation that will automatically protect the slopes, arrest deforestation. That's why unsustainable agriculture should be restricted, right? Unsustainable urbanization has to be restricted. You can even take up few structural measures where you can build barriers and retention walls to protect the communities below. If villages are already present in a vulnerable area, of course, you can't ask everyone to shift or move out, right? At least you create some retention measures through structural initiatives. And even if the landslide were to occur, it can withhold the material and protect the communities below. So, all these measures are needed along with emergency response and post disaster reconstruction, recovery, and rehabilitation to deal with landslides. Is that clear? So, this is how you prepare for these incidents. Now, let me present a case study here. Let me give you an example, a recent example. You might have heard about the Chamoli disaster. It happened very recently, just 2 years ago, in 2021. In the Chamoli disaster, which happened in Uttarakhand, there was a massive flash flood. All right? There was a massive flash flood in the Rishi Ganga and Dolly Ganga rivers. You're looking at a satellite image. That's why it looks different. It's a 3D image here. In the Rishi Ganga, Dolly Ganga rivers, massive floods occurred. Can you see this hydropower station here, the Tapovan hydropower station? This station was completely destroyed. Many workers who were working, they got trapped, they got killed, they were washed away. It was a very devastating disaster. Several workers were trapped in the hydropower plant which is under construction at Tapovan. Many were killed, many drowned, and some local communities, villages present here along the banks of Rishi Ganga, Dhauli Ganga, even they got flooded. So several lives were lost. There was a lot of damage to infrastructure. The hydro plant suffered a lot of damage, right? The infrastructure suffered damage. Property was damaged. So when this flash flood occurred, initially, it was estimated that it happened because of a cloud burst. Initial reports, especially in the media, as you know, our media, they jump to their own conclusions, even without verifying the facts. They jumped to their own conclusions. They relied on these so-called experts and they called it a cloudburst event which caused the flash flood. But later studies clearly established this happened because of a rock slip, which is like a landslide event. There was a massive slippage that had happened in the upstream, which was verified through satellite imagery. ISRO and ISRO and European Space Agency, they have few dedicated satellites to monitor the Himalayan mountains. The European Space Agency has a satellite network called the Sentinel satellites. ISRO also has few satellites in place to study the Himalayan ranges. These satellite images and the data revealed that an entire piece of rock and ice in the higher reaches of Himalayas had slipped. Can you see this image? You can notice a fresh marking here, this triangular area. It might look very small in the photo here, in the image. In reality, this is a very, very big piece of rock and ice. This entire piece had slipped and crashed into the water below, triggering a mini tsunami. That is what caused the flash floods. So this had occurred due to weathering, right? Natural process of weathering and erosion. And the Chamoli disaster gave us vital lessons that Himalayas are very sensitive. Ecologically, it's a vulnerable region already. There are many natural risks. Along with earthquakes, you have very weak slopes. The slopes are not mature, they're not strong enough. Due to such constant weathering and other natural processes, these slippages and landslides and avalanches are common. So what we should do is we shouldn't add to the problem. Human activity shouldn't contribute more, but our large scale construction, tourism, over exploitation, right, is increasing the risk in the Himalayas. That is why Uttarakhand is so prone to disasters. Every year it is witnessing multiple disasters. Is that clear? So that is a key lesson we should take from Chamoli disaster. Even though it's a natural event, see, this happened naturally. It's not that someone triggered it. But man-made activities are contributing to the overall weakening and destruction of the Himalayan ecology. Right? That is something we should keep in mind. Another example I would like to give is the massive floods witnessed in Kerala in 2017, 2018, in 2019 as well. There were massive floods and landslides all across Kerala and even in the Coorg district of Karnataka in Madikeri, which is an extension of the same range. Heavy rainfall during monsoons caused lot of flooding, triggering landslides, and later landslides would again trigger floods. Remember, yesterday we studied the cascading impact, how floods can cause landslides and how landslides can again cause floods. So this is a domino effect, a chain reaction. So Kerala also has become very, very vulnerable. This is again due to urbanization, exploitative tourism, unsustainable agriculture, deforestation. These human activities are increasing the risk factor. In Kerala, the problems have been specifically identified. Various studies have pointed out that the flow of water through natural rivers and channels has been blocked because of construction activities. Large projects have come up, roads have been built, resorts and homestays have come up everywhere, plantations have been taken up, forests have been destroyed, right? There is large scale abuse of the Western Ghats. So, this is directly contributing to more floods and landslides. So, these are two examples to understand the impact of human activities on these natural hazards. Is that clear? So, this completes my discussion on these important topics. We have covered cloudbursts and as well as landslides and avalanches. Now, if you have any questions, any doubts, let me know. I'll spend 5 minutes on that. And after that, we'll come to the next topic. We'll be talking about GLOF, Glacial Lake Outburst Flood. A very important topic because India has witnessed few GLOF events. The most latest event happened in Sikkim. Correct? Just a few days back, I mentioned this yesterday as well. There has been a massive GLOF event causing flash floods. Several people have been swept away. They have drowned and died. Many soldiers of the Indian Army, they're also missing. The death count can easily cross 100 plus, along with damage to infrastructure and the economy. So, this is another impending threat. There is a greater risk of these disasters happening in the future due to climate change and global warming. All right. So, let's understand this after taking up your doubts and questions. All right. Let's see the questions. Vivek is asking, sir, smaller area is a vague term with regard to cloudburst. Yes, you're absolutely correct. Because we don't have a universal definition of cloudburst. We don't have a specific criteria that IMD or other authorities have identified. Right? There's no clarity on how exactly you'll classify a cloudburst. That's why I told you it's controversial. Many media outlets, they report every heavy rainfall as a cloudburst. Right? So we need more studies. We need more research on this to clearly distinguish heavy rainfall from cloudburst events. There is one criteria which is rainfall of more than 10 centimeters per hour. The amount of rainfall has been determined, but the area has to be more specific, right? So this is where IMD has to provide more clarity. Doppler radars, sir, what is it? Doppler radars, they use sonar technology. right? They help in tracking clouds. They help in understanding the movement of clouds and understand how much water they bear. They help in understanding the density, right? The moisture levels that they are carrying. So based on that data, IMD can predict how much rainfall might be received and in which area and at what time. So Doppler radars are mainly used for tracking clouds. Chituri is asking impact of landslide and floods. Sir, how landslides impact floods? This I explained yesterday, right? I think you didn't attend the class. Please go back and watch the recorded lecture. To give you a brief summary, floods would have triggered landslides. We already understood that, right? The landslide material, the debris which is accumulated at the bottom, at the valley, that forms a blockage, right? In the valley, you'll always have a stream. You'll have a river or a water stream flowing through. So this blockage caused by the debris of the landslide becomes like a natural dam, a natural blockage. So water will start building up behind this natural blockage. So eventually, this natural blockage can't hold the large volume of water, right? The water which is building up will put a lot of pressure on the natural dam. So after a few hours or maybe after a few days, this natural blockage will burst open. It will break apart, causing sudden flow of water which is built up, causing another round of floods. That is the chain reaction between floods, landslides, and again floods. What is avalanche? I told you, right? Avalanche is a slippage of snow and ice in snow capped mountains. That is an avalanche. Himanshu is asking, explain the difference between rockfall and landslides. The phenomena is exactly the same, but in case of regular rockfall, it's usually big rocks, boulders that slip and roll down the mountain. All right. Whereas landslide involves the entire sheet of topsoil slipping down. In case of rockfall, only the large boulders and rocks will slip. Whereas in case of landslide, that entire top layer, as you saw in the image, will crash along with the soil, vegetation, and everything present on the slope. So there is only a slight difference between rockfall and landslide, but the phenomena process is exactly the same. Then Om Mangrulkar is asking GIS full form. Please don't ask full forms in class. That's not a question you should be asking in class, right? I've mentioned it. If you missed it again, please Google it. Don't ask full forms. Ask proper doubts, specific opinion based doubts, or if you need clarification on facts, not full forms. Next, Chituri is asking, in case of droughts, we can create artificial rain in those areas so that we can mitigate the disaster. Yes, this method has been tried by many states. Artificial rain can be induced, right? You basically spray aerosols like silver iodide, silver oxides. They're sprayed into the upper atmosphere, right, with drones or aeroplanes, right? You can spray these aerosols and they can induce the clouds to precipitate. But problem is artificial rains are not very effective. It's not that you can exactly control the process. It may happen, it may not happen, it may not be sufficient for the entire area, and also it's very expensive and it's resource intensive. So artificial rains, they do work to an extent, but not to an extent where droughts can be tackled entirely. But some countries have seen success, like UAE, for example, United Arab Emirates. They have enough wealth, they have enough resources. So they have invested a lot of money in creating artificial rains. And they've actually succeeded in bringing some rainfall and helping in cultivation of crops. But for a country like India, it may not be a feasible solution. It's very expensive, right? And also, it's not very effective all the time. Sangam Reddy is asking, Sir, El Nino affects droughts. Yes, definitely. El Nino, La Nina phenomena. You would have studied in geography, right? I'll not go into the details. This is disaster management, but just to give you an idea, Definitely yes, because floods and droughts, they're all influenced by rainfall, and our rainfall is mainly by monsoons, and our monsoons is directly influenced by the La Nina El Nino phenomena, right? El Nino has a positive impact, brings more rainfall to India, causing heavy rains, floods, etc. La Nina is bad news for India, usually, right? Currently, we are in the La Nina season. Last 2 3 years were El Nino seasons. That's why we saw good rainfall. But this year and maybe for another couple of years, we might witness La Nina phenomena, which is which is having a negative impact on the monsoons. So there could be lower rainfall, more drought situations, flash droughts, which affects agriculture as well. So definitely, La Nina El Nino phenomena influences the monsoon, that directly influences all your disasters, all your weather-based disasters. Sir, how civil engineering can help in these consequences? See, be it earthquakes, landslides, floods, cyclones, in all these measures, in all these disasters, by taking structural measures, you can protect your people. One way to tackle earthquake is to ensure your building is disaster proof. Ensure your buildings are earthquake resistant. Dealing with cyclone is by building cyclone shelters, retention walls. Dealing with floods, dealing with landslides will require construction. You can construct structures, right, to hold the water, to hold the soil debris which is slipping. That is where engineering comes in, civil engineering, right? Even to ensure your infrastructure projects are disaster resilient. It's all about construction. It's all about the design, the engineering that goes into it, the architecture that goes into it, right? So civil engineering plays a very big role in disaster management. All right. So guys, these are the questions. Now let's continue with the next topic, GLOF. It might take 10 15 minutes. After that, we'll take a short break because I know Sunday classes, weekend classes can be very tough on you guys as well. We'll take appropriate breaks in between so you're fresh, your mind is active, because the whole purpose is to ensure you guys concentrate in class, right? What's the point if you're dozing off in between? And I understand some topics can get boring. Trust me, I'm trying my best to make it interesting, and I hope you guys find it interesting. But definitely the breaks become important in between. So let's continue for 10 15 minutes. That's it. We'll finish this and then we'll take a break. All right. GLOF, Glacial Lake Outburst Flood. What is it? How does it happen? What is the impact? That's all we have to understand. As the name itself indicates, in this disaster, there is a glacial lake which is bursting, which means the water is getting released all of a sudden. And what happens when there is a sudden release of large volume of water? Obviously, it will cause a flash flood, which in turn can cause landslides. This is the sequence of events. There are glacial lakes in our Himalayan ranges. All right. How are these glacial lakes formed? Very simple, by the melting of glaciers. Now, don't ask me what are glaciers. I hope everyone knows what's a glacier, right? It's a massive ice sheet, almost permanently frozen. So, these ice sheets, the glaciers, which are the source of many rivers, they melt naturally. There is a natural melting rate with changes in temperature, changes in seasons. Glaciers, they melt naturally. So, all the water that is arising out of this melting process, it accumulates at the bottom, causing the formation of a small lake. A small water body gets formed. If you guys have ever been on a trek in the Himalayas, let's say Uttarakhand, Himachal, or Sikkim, right? You would have definitely noticed such glacial lakes at the higher reaches. I'm not talking about the easy treks. For this, you have to do a very difficult trek, which involves you reaching very high altitudes, right? There are professional trekkers who do that. There are many amateurs who join them as well with some training. So if you have ever done one of these high intensity treks reaching very high altitudes, there you would have seen these beautiful lakes, pristine waters, right? And it's present right next to a massive block of ice. That is your glacial lake. These glaciers, they melt naturally. The water accumulates in this lower area, right? That becomes your glacial lake. This is what feeds many rivers as well later. Now, so there is a man-made factor here which has accelerated the melting rate. The rate at which these glaciers are melting has accelerated, contributing more water into the glacial lake. All right. Now, in this glacial lake, the water is being held by very loose structures. There will be a lot of water which builds up over years, over decades, over centuries. This entire water, it's like a reservoir right now, it's like a dam. All of this is being held by very loose structures, natural structures. All right. You have something called as moraine. Moraine is all the organic waste material, right? Accompanied with soil, some debris. All of this accumulates to create these loose barriers around the water body. That is like the wall, the retention wall, like a dam gate which is holding this lake together. Now, these moraine structures, the embankments, the natural embankments which are there, they could be breached due to many reasons, many factors. There are many possibilities where this lake can burst, where these loose embankments and structures might break, causing a sudden flood in the downstream. Is that clear? So definitely man-made factors are increasing the risk because of faster melting of the glacier. More and more water is getting accumulated in these glacial lakes, which could be beyond the holding capacity of the lake itself. These loose moraine structures may not hold the water forever. At some point, it's going to breach and break apart. And there are other triggers, natural triggers, which might cause these outbursts. For example, let's say there is a landslide, there is a rock slip, or there is an avalanche in these higher reaches. Right? This could happen in the Himalayas. Maybe there is a huge earthquake that induces tremors, the shaking of the entire surface, causing a rock slip or a landslide or an avalanche. Now, if this material suddenly crashes into the lake, if all the material crashes and collapses into the lake, it will create a mini tsunami. What's a tsunami? Tsunami is an outburst of water triggered by some event. Right? A true tsunami happens in the seas, and the oceans. But phenomena is the same. Now I take a bucket of water filled with water to the brim and I drop a huge stone into it. What will happen? The water will spill out violently, not a gentle spillover like in a regular flood. It's a violent, sudden spillover, right? It's like a mini tsunami. The phenomena, the process is the same. So if there is a landslip, rock slip, avalanche, maybe triggered by an earthquake or by erosion, this material which is crashing will push the water out, and the loose structures, the moraine structures which are holding it, will break apart, causing floods, flash floods, and more landslides in the downstream. This is one possibility. It will cause more flash floods and landslides. You can see how villages get submerged, power cables, roads, everything could get destroyed, right? So there will be loss of life. There will be damage to property and infrastructure. That's how it becomes a disaster. There are many more possibilities. Let's say there is heavy rainfall or heavy snowfall, right? This could also be accelerated by climate change because of extreme weather, which is driven by global warming. There could be unnatural amounts of rainfall and snowfall, right? the snow might melt, the water would accumulate here, and this sudden infusion of water, excess water, could also cause the barriers to breach. The glacial lake could breach on the outside barrier, and the water will suddenly move out in one motion, right? So this sudden flow of water down the stream will cause flash floods and landslides. So this is what we call as a GLOF event. So what happens later is exactly like flash floods and landslides. It's exactly the same. Understanding GLOF phenomena is the most important point over here. Understood? So these glacial lakes are formed by the melting of the glacier, melting of the ice sheets present in the Himalayan ranges. Clear? These glacial lakes are loosely held, and the volume of water is increasing due to global warming, due to accelerated melting of the glacier. Along with that, other factors like earthquakes, snowfall, landslips, avalanches, they can breach the integrity of the lake, causing the water to flow out in a sudden motion. It's like bursting a dam. Let's say from a dam which is filled to the brim, water is suddenly released. Or let's say there's a complete breakup of a dam. Let's say there's an explosion, or the dam is old, it loses the integrity and collapses. What will happen when the water gushes out? It causes a flood. The same thing happens here. This is what happened in Sikkim. All right. Now I'll give you a small exercise, a small assignment. Find out the glacial lake that burst in Sikkim. Find out the name. I want the name. Do this basic research, right? It happened just few days back. Read those articles. Find out the name of this glacial lake which burst open, causing these floods, flash floods in Sikkim. Next, the next important point. What is the vulnerability? Vulnerability is dependent on the distribution of glacial lakes in Himalayas. So all across Himalayas, there are thousands of glacial lakes. Studies have established that we have more than 25,600 glacial lakes. Starting right from Hindu Kush ranges near Afghanistan and Central Asia, all the way through Pakistan, India, Tibet, Nepal, then Bhutan, and close to Myanmar. Across this entire stretch, we have a total of 25,614 glacial lakes. Is that clear? That's why the Himalayas, they're referred to as the third pole of the world. Just like North Pole and South Pole, like Arctic and Antarctic, which holds massive amounts of ice. Similarly, Himalayas is holding massive amounts of ice. So it's often referred to as the third pole of the world. Many of these glacial lakes are vulnerable. They're not held by very strong structures. They might break apart easily. So we humans have contributed to the risk through global warming, where glaciers are melting at a faster rate, adding more water. Other than that, any risk factor like landslides, earthquakes, avalanches, heavy rains, or even human activities can result in the disruption or the breach of the lake, causing these floods and landslides. Is that clear? So these lakes are present across all the major river basins. Brahmaputra basin has the highest number of these glacial lakes. From Tibet all the way towards Sikkim, Bhutan, Arunachal Pradesh. This whole belt has the maximum number of glacial lakes, followed by the Indus basin, then the Ganga basin, Amu Darya towards Central Asia and Afghanistan, and Irrawaddy basin towards Myanmar. Understood? These are the major river basins of the Himalayas where these glacial lakes are present. The Amu Darya basin from Central Asia to Afghanistan to Pakistan, the Hindu Kush region, right? Of course, this is occupied areas by Pakistan, the Gilgit-Baltistan region. Then you have your Indus basin covering Kashmir, Ladakh, parts of Tibet, parts of Pakistan. Then the Gangetic range, Tibet, Nepal, and India, right? Then you have the Brahmaputra range and the Irrawaddy range. These are the five major basins, and in total, we have 25,000 plus glacial lakes. So studies have shown that many of these lakes are at risk. All right. You take the Sikkim incident, the glacial lake which burst open, it was being studied from at least 15, 20 years. Researchers in India and abroad, they had enough scientific data to point the risk. There was satellite data, ground level studies were conducted. All the studies were showing that the glacial lake size was increasing year by year. The risks were flagged by many experts, but enough action was not taken by the governments. Right? That is why the government of India and the Sikkim government are facing criticism, because hundreds of people have been lost, including soldiers of the Indian Army. Right? So accountability is important. The blame has to be fixed. Despite knowing the risk, enough measures were not taken, and that is the mistakes that can happen in disaster management. Right? So what can you do with regard to GLOF events? First, carry out the risk analysis. Understand the presence and distribution of glacial lakes. Map them out and constantly study them, monitor them. So you need to use satellites and drones effectively for this purpose, because the terrain where the glacial lakes are present is very tough, very complicated. We may not be able to reach all the glacial lakes. It could be physically impossible. So satellites and drones, even aircraft, can play a big role in helping us mapping out all the lakes, studying them, monitoring them constantly. Not once in a blue moon, but constant surveillance and monitoring. Through these studies, you can figure out which of them are at greater risk. Just like the glacial lake in Sikkim was flagged many years ago. From 15 years, there were warnings that this lake might burst any day. Right? So those studies can help. It can provide us early warning. Have you heard of synthetic aperture radar technology? It is used in satellites. It's used in drones and aircrafts as well. This helps in surveillance. The advantage of synthetic aperture radar is that it can function 24/7. See, in regular Earth observation platforms, optical instruments are used, optical lenses. In your satellites, your drones, and aircrafts, to take aerial images, optical cameras are used. But optical cameras have a limitation. The limitation is they don't take good images during night when it's dark. They give you good images only during daytime. Next, optical cameras cannot penetrate cloud cover. If there is cloud cover, they won't take good images. Right? That's why optical camera based Earth observation satellites are not very effective, be it for border security, defense, surveillance, intelligence gathering, or even for disaster management. A better technology is synthetic aperture radar. Synthetic aperture radars can capture very high resolution pictures even during night time. Even they can penetrate cloud cover. Even if there is dense cloud cover, they can penetrate the cloud cover and still give you real time surveillance. So such technologies have to be deployed more and more. We already have them. ISRO already has few satellites in orbit which have synthetic aperture radar as a payload. Have you heard of RISAT satellites? The RISAT series, these are military satellites, mainly for observing the borders, to keeping check on infiltration, to check the movement of the enemy. Right? The same satellites can be deployed for disaster management as well, to constantly monitor the glacial lakes. Based on that, you take your regular measures. We don't have to explain and study them again. It's the same measures as flash floods, same measures as landslides, because that is the final impact. Right? You don't have to do anything else. Once you identify the risk, once you identify the most vulnerable glacial lakes, right? You start working on the same measures as that of floods and landslides. Try to strengthen the glacial lake if practically possible. If not possible, take other measures, put in place early warning systems. Ensure that you regulate construction and human activities in the downstream. Prevent human settlements from coming up. Keep them at a safe distance. Try to divert the flood water if it were to happen. So the same exact measures, right? Same measures as floods and landslides. You don't have to repeat them again. So these measures will help you apart from risk analysis and vulnerability mapping. So this completes the small discussion on GLOF. It's a very small topic. You understand that phenomena and the risk, it's enough. Everything else is the same as floods and landslides. The reason why I discussed it in detail is because we have seen many such events in India and even around the world. So, since it's in current affairs, because of the latest disaster in Sikkim, UPSC might ask you a prelims question or a mains question. So, please be prepared for that. So, before we start with the next topic, I think we can take a short break. Let's take a 15 minutes break. It's almost 3:41. Please come back by 3:56. All right, let's meet in 15 minutes and then we'll start with the next topics. Hello, everyone. Welcome back to the session. Now, first, let's look at some doubts and questions based on the previous topics we have covered. And then we'll start with heat waves and cold waves. Jayant says, why don't we create some rules for landslide areas for allowing only limited people in that area? See, this is what land use planning means. This is the purpose of zoning standards, and we already have those rules. With regard to some hazard prone areas, under land use planning, zonal standards have been brought out. Problem is not with the lack of rules. Problem is in enforcement. As I told you at the ground level, there is corruption between local governments and the construction and real estate industry. Many illegal structures which come up on encroached land, they are eventually legalized. So there is very poor implementation, poor enforcement, right? That is why these disasters have a bigger impact. Avani is asking, sir, why doesn't the introduction of fresh water by rivers not decrease the temperature of Bay of Bengal? No, it's actually the contrary, because fresh water coming from the landmass, coming from rivers, is warmer, not cold, right? In the seas, and in the oceans, if you look at the bottom layer, right, where the cold, dense water has settled, those temperatures are very low. Compared to that, the fresh water flowing from rivers through the landmass is actually warm. So it does not bring down the temperature, rather, it increases the temperature. It doesn't allow the warm water at the top to mix with the cold water below when there is a constant fresh water coming in through the rivers. So that is the reason why Bay of Bengal has higher sea surface temperature. And I also see that many students have given the answer to the small assignment I gave you. Himanshu, then Abhinav, Ankita, Chituri, all of them have got the right answer. The glacial lake which burst in Sikkim in the latest Sikkim disaster, the glacial lake which burst was the South Lonak Lake. The South Lonak Lake. Very good. That's the correct answer. The South Lonak Lake had been studied from many years. Researchers had warned that the glacial lake is expanding due to melting of the glacier. They had warned that the integrity of the glacier is becoming weaker, but still enough measures weren't taken, and this was a avoidable tragedy which has occurred. See, we couldn't have prevented the outburst, that's a natural process, but we could have at least ensured that the downstream areas were protected. With better planning and preparedness, we could have limited the human settlements, regulated human activities, thus saving lives. Unfortunately, this wasn't done, and as a result, we have had a huge impact in Sikkim. So, in the downstream of the Tista, right, that's where the flash floods were seen. Hundreds of people have been lost, many obviously are killed. Many Indian soldiers of the Indian Army also have been washed away. All right, next, any other question? Anything else? Vivek is asking, Manas Sarovar Lake, is it related to Kailash, sir? Correct. Near Mount Kailash in Tibet, you have the Manas Sarovar Lake. Both are very important pilgrimage sites in Hinduism. So the Manas Sarovar region that you see here, which is marked in the map, it refers to the Manas Sarovar Lake. You also have another important lake here, Rakshas Tal. Right? Both are very important pilgrimage sites in Hinduism near Mount Kailash in China, in Tibet. Chituri is asking, what is flora and fauna? Come on, you can't be asking this question, right? These are very, very basic questions. Don't expect me to even answer this question. All right. So, guys, these were the questions. Now, let's start with the next topic. Let's start with heat waves. First, we'll discuss heat waves and then I'll come to cold waves. Let's finish these two by the next break. And after that, we can look at earthquakes, tsunamis, etc. So, a heat wave is actually a deadly disaster. It's a result of abnormally high temperatures in a given region over a given period of time. Obviously, it occurs only during summer season. During peak summers in some parts of the world, abnormally high temperatures are recorded. Now, what do you mean by abnormally high temperature? It means if the actual maximum temperature being recorded at a place, if it is many times higher, if it is significantly higher than the normal maximum temperature of that place, this marks the beginning of a heat wave condition. There is a specific criteria as well that IMD has identified. We'll take a look at that as well. But first, understand that heat waves occur when actual maximum temperature, which is being recorded in that place, if it is many times higher, significantly higher than the normal temperature expected. This temperature departure, this difference, is what causes the heat wave condition. So it's a feature of peak summer in few parts of India, especially the northern and western parts of India, northwestern India, and south central parts of India. They are the most affected. So from Delhi and the NCR region, parts of UP till Bihar, parts of Madhya Pradesh, Rajasthan, right? Parts of Haryana, interior Maharashtra, Karnataka, Telangana, some parts of Chhattisgarh and Odisha. This belt is the most prone for heat waves. Essentially, where you have arid, semi arid conditions, where you witness drought conditions, they witness these record temperatures, record breaking temperatures during peak summer. And if the departure is significantly higher than the normal expected temperature, then heat wave alerts are declared. So we usually see this between the months of March to June. All right, that is before the monsoon begins and as the summer sets in. That's where we witness heat wave conditions. By January, the winter almost comes to an end. February is usually spring. By March, proper summer will set in India. By April, May, temperatures will start peaking, right? This is the peak summer, especially April and May. And by end of May, monsoon will set in. By June, most country would be covered by monsoons. Then the temperatures will come back to normal. So during this period, from March to June, especially in April and May, that is when we witness these extreme conditions. In rare cases, it might extend to June, July, but it's very, very rare. All right? Because in northern India, the summer extends because the monsoon arrival is delayed. Summer could extend all the way till July, June, July as well. Right? So it's very rare to see heat waves in June, July, but it's possible sometimes. But usually it's from March to June, especially April and May. These extreme temperatures, they can have a devastating impact on all living forms, human beings, animals, birds, aquatic life, right? It has a devastating impact on all living organisms because our physiology, human physiology is such that it functions properly only at ideal temperatures. If the temperature shoots up beyond a point and if you are exposed to this extreme heat, your bodily functions are directly affected. There are many adverse, serious consequences, health consequences that arise out of this, which could even lead to death. Is that clear? People get killed because of exposure to heat wave conditions. That is why it is a dangerous disaster. So let's understand more about this. Of course, climate change is playing a role. The rise in average temperatures because of global warming is also driving more heat wave conditions around the world. So there are many examples I can give you. In India, right, every single year, Hundreds of people might lose their lives in northwestern India and south central parts of India. The unfortunate thing is that many of the deaths are not even recorded. Since you can't really attribute each and every death to heat wave, right? Many times there is a wrong diagnosis in the hospitals as well, or after the death has occurred. They would attribute the death to some other cause. So the real count may not be available. Even those that are recorded, the numbers are quite high. At least few hundred people lose their lives during the peak summer due to these oppressive heat wave conditions. Every year we witness this in India, in northern India, western parts of India, central and south, some southern parts of India. So this is the hazard map. This is the hazard vulnerability map. You can see that from the Delhi, Punjab, Haryana belt to parts of UP and Bihar, covering some parts of Chhattisgarh, Jharkhand, Odisha, Rajasthan, Gujarat, the almost the whole of Madhya Pradesh, Maharashtra, some parts of Karnataka, Telangana as well. So these are the regions which witness heat wave conditions. All right. Now, globally, there are many examples. Recently, we witnessed a deadly heat wave in southern Europe. You might have read this in newspapers, right? In Italy, in Greece, Spain, Portugal, essentially all across the Mediterranean region in southern Europe, deadly heat waves were witnessed this year. Many tourists were caught because tourists usually come to Mediterranean region in the summers, right? Especially from the colder parts of Europe, like let's say Germany or even France, Belgium, UK, Finland, Norway, even from US and Canada. A lot of tourists come to the Mediterranean region to enjoy the European summer. So lakhs of tourists, they were stranded during these deadly heat wave conditions, which even triggered massive wildfires. Deadly forest fires were witnessed in Italy, Greece, and other parts of Mediterranean, which disrupted the tourism industry. Is that clear? We have seen such deadly heat waves happening in US, in Canada as well, even in Australia. So this has been the worldwide impact of heat waves. So let's see how we can identify the condition. What is the criteria used to declare a heat wave condition? Which is the nodal agency? And what is the impact on humans, impact on the environment, impact on the economy? Let's study all of this and then discuss the disaster management approach. The nodal agency is of course IMD, because temperature is again a weather phenomena, meteorological phenomena. So India Meteorological Department is responsible for tracking temperatures in the country. So any abnormal shift, be it extremely high temperatures, extremely low temperatures causing cold waves, for all these events, IMD is the nodal agency for early warning and forecasting. Fortunately, we have enough technology to provide accurate forecasts. Unlike rainfall, where the forecast is not very accurate, temperature forecasts can be very accurate. Due to advances in weather forecasting and other technologies like satellite technology, it's quite easy today to provide very accurate forecast for the entire week, even for up to 10 days. So IMD is responsible for tracking temperature levels. Any abnormal departure, either too high or too low, causing heat waves and cold waves respectively, both are tracked by IMD and it gives prior alerts. Since forecasting is available and since it is accurate and reliable, prior forecast and prior alerts are given. So few days before, you know that heat waves are going to start. You know that cold wave conditions are going to set in. So accordingly, you can take preventive measures. See, this is only a hazard. It can't turn into a disaster unless we allow it to happen. By taking some right precautions and right measures, we can prevent this from turning into a disaster. We can at least save human lives. Is that clear? So let's see what is the criteria used by IMD. See, UPSC will not ask you the criteria. All right. This is just for your additional knowledge. Just have a fair idea on how heat waves are predicted. You don't have to mug it up. You don't have to sit and by heart the criteria. It's a little technical. So don't do that. Just for your understanding, take a look at how IMD bases its heat wave alerts on. Now, the IMD has first set a threshold. It has set a threshold depending on the altitude of the place. To even consider a heat wave condition, right? The place given, it's a plain area or a mountainous area or a coastal area. For all these places, a basic threshold has been set. Only beyond this, heat wave conditions are considered. This threshold is 40 degrees for plains, 37 for coastal stations, 30 degrees for hilly regions. Is that clear? Now, why do you think different thresholds are set for these areas? Can you tell me? Any idea? Why do you think it's 40 degrees for plains? Why is it higher in plains? Why is it only 37 in coastal areas, 30 for hilly areas? There must be some reason. Why is the threshold varying with altitude? What does altitude have to do with this? Avani has given the right answer. Very good. See, the temperature of a place and the heat that you feel, that you experience, they are dependent on humidity levels as well. Humidity varies with altitude. Temperature varies with altitude. The heat that you feel and perceive, your body, what heat it feels, right? It experiences. It changes with altitude also. On your phones, if you get weather alerts, you will notice that actual temperature is, let's say, 27 degrees. On the side, it would be written, but it feels like 29 degrees. Even though temperature is 27, it feels like it's 29. Have you ever seen this on your phones? If not, please observe that. So it means that actual temperature will be something, but what we experience could be slightly higher or slightly lower, depending on humidity levels, the altitude of the place. Is that clear? So in a hilly area where lower temperatures are the normal, even 30 degrees is actually significantly higher temperature. In plain areas, which are almost at sea level, right? Coastal areas which are at sea level, their humidity levels are much higher. Now, why do you think Mumbai and Chennai feel so oppressively hot? The moment you go out in Mumbai or Chennai, you start sweating profusely, right? Even if it's just 30 to 35 degrees, you start sweating very profusely. The same will not happen, let's say, in Bangalore, right? There's a reason. Bangalore is located at a good 3,000 feet above sea level, almost 1,000 meters, 1,000 meters above sea level. Whereas Mumbai and Chennai are at sea level, at coastal areas. So as the temperature and the humidity levels vary with altitude, so the heat we perceive, the body perceives, also changes. So what changes happen to our bodily functions in different heat conditions is different from location to location. So let's say in Mumbai, which is a coastal area, even at 35 degrees, I'll feel exhausted if I go for a walk. But let's say in Delhi, even if it's 39 or 40 degrees, I'll not feel that kind of exhaustion as you feel in Mumbai or Chennai. Because the amount your body sweats is also dependent on these factors, humidity levels and the temperature, right? By the way, sweating is your body's way of regulating your internal body temperature. Your body will throw out the excess heat. It's like a natural ventilation, cooling mechanism of the body. As I told you, our internal organs, our body physiology functions only when ideal temperatures are maintained. If the body temperature shoots up, automatically the mechanisms kick in, the physiological mechanisms, right? The body will throw out the excess heat by sweating. So this process could get disrupted under extreme heat. If you're constantly exposed to extreme heat, your bodily functions will get disrupted. It will be thrown out of gear. All right. So this minimum threshold is identified for plains, hilly areas, and coastal stations. Heat wave is considered only if the threshold is met. That's one basic criteria. Now imagine if the criteria is met. Let's say in plains, 40 degrees above is present. In coastal areas, 37 degrees above is present. In hilly areas, 30 degrees and above is being recorded. Only then the temperature difference is taken into account. The difference between normal temperature and actual temperature. Now, if your actual temperature being recorded on that day, if it is higher than the normal, and if this is recorded for 2 consecutive days at 2 stations, and if the difference is more than 5 to 6 degrees from the normal for plains, if the difference is, let's say, more than 5 to 6 degrees in hilly areas and in coastal areas, where the normal is actually expected to be less than or equal to 40, right? In hilly and coastal areas, we expect the normal to be less than or equal to 40. In such places, if the departure is more than 5 to 6 degrees, or in plains where temperature expected, that's the normal temperature, is more than 40, and if the departure is more than 4 to 5 degrees, right, then a heat wave alert is declared. Let me summarize this again. I know it's complicated. That's why I told you it's a little technical. First, there is a threshold for hills, plains, and coastal areas, right? This is to account for altitude and humidity levels. This is the minimum criteria needed. Anything below this, heat wave is not even considered. Once the threshold is up crossed, then the second criteria comes into action. It comes into picture. Now, let's say actual temperature in a place where normal temperature is expected to be less than or equal to 40. This is usually in hilly areas and in coastal areas. Here, if the departure is more than 5 to 6 degrees, then it means a heat wave has started. All right. This departure has to be recorded for 2 consecutive days, 2 back-to-back days at 2 different stations in that region. Similarly, in areas where normal temperature is expected to be more than 40, normally it should be above 40. In such a place, if departure is more than 4 to 5 degrees, then it means heat wave has started. And there is another third criteria, a master criteria, which overpowers the first two. The third criteria is independent of the first two. If actual temperature remains 45 and above, irrespective of the place, irrespective of normal temperature, it means heat wave conditions have started. Is that clear? These are the 3 basic criteria used by IMD. Now let's take an example that will make it more simpler for you. Let's take New Delhi. New Delhi is a plain area. It's not a hilly area. It's not a coastal area. It's a hilly area. It's a plain area. So what's the threshold here to even consider heat wave? 40 degrees. That's the minimum expected. Now let's say it's peak summer in Delhi. Let's say it's April or May. Now, normal temperature in Delhi is expected at 41 degrees. That is what is expected. But let's say the departure is more than 4 to 5 degrees. This point, the second point here, the second point under statement 2. Let's say the actual temperature getting recorded is 46 degrees. There is a clear departure of 4 to 5 degrees or more. It means that Delhi now will experience a heat wave. But this should be recorded for 2 days at 2 places. Got it? So in a plain area like Delhi, the threshold is 40 degrees to even consider a heat wave. Let's say normal expected is around 41. But for 2 consecutive days at 2 stations, we are recording 46, 47 degrees, which means this criteria here is met. This criteria, where the normal temperature is expected above 40 and the departure is more than 4 to 5 degrees, it means heat wave has started. Understood? We'll take one more example. Let's say we'll take a coastal area. Let's take Mumbai. Mumbai is a coastal area. So what's the threshold? 37 degrees Celsius. This is what is expected to even consider a heat wave. Now, normal expected is 38 degrees. But if actual temperature is 5 to 6 degrees above, if it is more than 5 to 6 degrees, which means, let's say, 45 degrees is being recorded, it means the threshold has been breached. The criteria has crossed. So if this is recorded at 2 places for 2 consecutive days, then a heat wave alert will be declared. Is that clear? These are just hypothetical examples I'm giving. Mumbai usually does not witness a proper heat wave because coastal areas have a moderating influence. The sea breeze, right? The presence of the seas or the oceans, they bring in a breeze that cools down and moderates the temperature. Usually it's in interior land mass that heat waves are witnessed. All right. I'm just taking these examples to make it easier for you to understand. Clear? Now, irrespective of the first two criterias, if in any place constantly 45 degrees is being recorded, 45 and above for 2 days, then heat wave is declared. The threshold will not matter, altitude, the departure, nothing will matter. If in a place for 2 days 45 degrees and above is being recorded, right, it means heat wave has started. Is that clear? So this is the established criteria by IMD. Understood? I'm repeating again, don't sit and by heart this. Don't do that. This was just a general information for you, general understanding for you, because it is important to know how these things are identified, right? It just improves your common knowledge. Maybe it will help you in the interview if there is a related question, but definitely not in the exam. UPSC will not touch this topic. All right. Heat wave topic is very important, but how it is measured, how it is identified, that is not important. Don't by heart, just understand the basic concept. Next, what is the impact? What will happen if there is a heat wave? What will happen to our body? What will happen to the environment? Right? That is something we should concentrate on. Now, if you are exposed to this deadly heat wave condition, exposure is very important. During the peak hours, especially from 10 a.m. to 4 p.m., right? This is where you get the peak heat. Sometimes it will start by 9 a.m. as well in some places, going all the way till 5, 6 p.m. But usually it's between 10 to 4. Now, if you are exposed to this condition, let's say you're an athlete, you're playing in the outside, exerting yourself, you're playing a sport, you're running, you're playing cricket, you're playing football, any sport, you're exerting yourself in this peak heat. Your body will start throwing out the heat through massive sweating. So, what will happen when you sweat excessively? You're going to get dehydrated. Your body will lose the fluids, the essential fluids, and even the electrolytes. All right? Dehydration can lead to heat exhaustion. Heat exhaustion is not your normal exhaustion where you feel tired. You just go for a half an hour walk, you feel tired, right? You attend a class, you feel tired. That is not exhaustion. Heat exhaustion is different. You feel nauseated. You feel like vomiting, like throwing up, right? You lose your balance. You get confused as well. This is classic symptoms of heat exhaustion. It is severe exhaustion where your body is severely dehydrated. The essential fluids, water has been lost due to excessive sweating. The salt balance, the electrolyte balance is getting upset, and this starts affecting your bodily functions. This could induce heat cramps and heat strokes. It could cause swelling internally. You can even start witnessing a fever. All right? You will feel weak, fatigued, dizzy, nauseated. You'll start vomiting as well under heat exhaustion, and your muscles will cramp up. Muscle cramps are very common. You'd have seen athletes, they cramp up regularly. Why? Because they're exerting themselves, they are getting dehydrated. So if they don't take enough water and electrolytes, they will suffer from muscle cramps. It's a classic sign of heat exhaustion. Then comes the last step. Even now, if you don't get intervention, if you ignore these symptoms thinking it's some normal infection or something, if you don't pay attention to it, if you don't get diagnosed and treated, right, you're going to go to the next stage where you'll suffer a heat stroke. Heat stroke is deadly, it's fatal. There could be seizures, which could push the patient to coma. It could lead to multi organ failure. Your internal organs will start failing. It could even lead to a cardiac arrest, finally causing the death of the person. Your core body temperature should be at ideal levels, right? And there is a way in which the body maintains that core body temperature. But if you are exposed to this heat and you're getting exhausted, losing fluids, getting dehydrated, this is the outcome. Starts with exhaustion, cramps, leads to a stroke, leading to multi-organ failure, heart attack, and a final death. Is that clear? Now, the biggest risk is for the poor people. The risk is the highest for athletes because they have high exposure, and poor people who are forced to work in the open. Street vendors, manual laborers, construction workers, rickshaw pullers, then even those who lift weights as a profession, like in markets, in shops, right? There would be daily wage laborers whose only job is to lift heavy weights in the open, to load the trucks, unload the trucks. These are physically exhausting tasks. And if they continue with these tasks in the peak heat, when heat wave is going on, they will suffer from dehydration, heat exhaustion, cramps, and eventual stroke. Is that clear? So as a result, heat waves, they have a disproportionate socio-economic impact. The rich are never affected by this. Even middle class, lower middle class will not be affected by this. I told you yesterday as well, right? There is a big socio-economic difference here. This is one disaster. In fact, you see this in every disaster. But in the case of heat wave and cold wave, this is more evident. The social difference, economic divide, income divide, makes a bigger difference here. See, earthquakes will not spare anyone. Just because you're rich, you're not spared by the earthquake. Just because you have a bungalow, right? Your building will not stand if it's not earthquake proof. Same with cyclones, tsunami, floods. They don't usually distinguish. But heat waves, they do distinguish. Cold waves, they distinguish. Because those who can afford the luxury of not having exposure, they don't face anything. People won't even realize there is a heat wave alert, there is a disaster going on, right? I'm sure many of you never bothered about a heat wave alert, right? Because we sit in the comfort of our homes, we travel in air conditioned cars, we sit in corporate offices, we go to shopping malls where everywhere it is air conditioned. You never feel the heat, right? Your body cools down. Cooling solutions are available to you. Even if you get exhausted, let's say you went on a trek, you went on a walk, or you did some physical work, you do feel dehydrated and exhausted, you always have access to water, you have access to electrolytes, juice, whatnot, right? You can switch on a fan, a cooler, or an air conditioner. Now these are luxuries, these are not basics, these are luxuries compared to what the poor people have. They can't afford this. As I told you yesterday, you might cancel your class, sit at home, right? You may not go to work from home. You have plenty of options to avoid the heat. Workers don't have that. Street vendors have to open their outlets, they have to do it on the street, or else their family will go hungry that day. Construction workers, daily wage laborers, rickshaw pullers, they have no other option. They continue working in the open and they get exposed, and they suffer the biggest impact. 99% of them who die because of heat waves, they're all poor people. They're all from the lowest sections of the society, right? Athletes are the other category, but that's a different case. That's their occupation related hazard. That way, even civil engineers who work on site, even they are exposed, right? But that's a different category. They still have an option to protect themselves. But poor people who are forced out of their economic necessity to work despite the alert, they are facing the biggest risk. They are the most vulnerable. Understood? The same applies for cold wave as well. We'll see that later. Now, what can we do with regard to disaster management? How can we save more lives? How can we prevent this from becoming a disaster? First of all, early warning is easily available. Risk analysis is done. We know which regions are affected. It will happen every year, and it's very easy to predict and forecast heat wave conditions. So IMD is doing a very good job. It's already issuing right alerts, communicating this to all the government authorities, communicating to the media, to the people, right? Now, the government authorities, the disaster management authorities, they have to create and protect the natural buffers. That's one step. That's one part of planning and preparedness. The more you protect your natural buffers, it will help in moderating the temperature. What's a natural buffer in this case? Lakes, forests, wetlands, even parks in your cities. They're all natural buffers. Is that clear? If these are protected, conserved, they will help in moderating and cooling down the temperatures slightly. And it also provides shade for people to rest. Temperatures will moderate if your natural buffers are conserved and protected. That's why near lakes, near water bodies, near forests and parks, the temperatures are slightly lower, right? It helps in moderation of the temperature, and more importantly, it will give shade. These are public areas. Poor people can have access to it, right? They can't afford to go back home. They can't afford to shut down their business and go back for the day. For some time, they can take rest. For a couple of hours, they can rest, take some water, take some electrolytes, and thus they can avoid the disastrous impact of heat wave. These become shade places or rest places. The public service authorities, your discoms, water supply boards, municipal bodies, panchayats, they have a critical job. When heat wave alerts are present, they have to ensure that water and electricity is not cut, ensure there is no load shedding, because electricity is needed to run fans, coolers, and air conditioners. That's a cooling solution, right? Basic water is critical. This is what keeps you hydrated. Strengthening the public health infrastructure, government hospitals especially, they should have a strong infrastructure to deal with these cases and to correctly diagnose and treat these patients. Because poor people, they will not go to private hospitals when they get these symptoms. They will not even realize it's a heat wave condition they're suffering from, right? So they will, let's say they get nauseated, they feel like vomiting, they suffer from cramps. They will go to a government hospital, they'll go to a local uh, primary healthcare center. Now here, if the doctors don't diagnose this as a heat wave condition case, and if they don't treat them properly, if they don't give them electrolytes and fluids, the patient will still suffer from heat stroke. Patients will still die because of wrong diagnosis. Let me tell you about one very unfortunate case that happened recently. Just last year in Bihar, many patients came to a government hospital over a period of few days. They all had same symptoms: nausea, vomiting, muscle cramps, tiredness, exhaustion, confusion. Around, I think, 40 to 50 patients or more than that, they came to these government hospitals. They reported the same symptoms. In all the cases, the doctors were wrongly diagnosing it because there was no awareness, no concern about the patients coming in. They were all put on some wrong medications, sent back home saying it's some normal symptom. But majority of them died later because they weren't put on the right treatment. They didn't get access to cooling solutions. They didn't get access to hydration. In this case, when you already suffer from exhaustion and stroke conditions, water alone will not help. You need electrolytes, you need other fluids which has to be administered. But this was not given, and more than 30 people died. This is what has been accounted for. Imagine how many unaccounted deaths would have happened. Even after coming to the hospital, due to wrong diagnosis, people have lost their lives, and all of them were from the poor category. No one was from lower middle class, upper middle class, or the rich category. They were all poor people working in the open. The doctors, they failed. They didn't see the connection. They wrongly diagnosed the cases, and these deaths occurred. Is that clear? So, strengthening your health infrastructure, training your health institutions, keeping the doctors on guard. They should know that a heat wave alert is there. These patients who come with these symptoms are likely suffering from heat exhaustion, and the right treatment should be given. If that is provided, all the patients will survive. Deaths can be zero. This is preventable. Trust me, it's a preventable disaster. It requires more awareness as well. People have to be aware, right? Especially the vulnerable category, they should know what is happening to them. They should know that there is a heat wave alert. So government has a duty here to educate them. Government has a duty to create cooling places in the public, create shelters, right? Provide them with fans and coolers at least. Create public water provisions. Provide for drinking water in public spaces. Provide cold water. It actually helps in bringing down the body temperature when you're suffering from heat exhaustion. Next, strengthen your firefighting capabilities because fires will break out. Forest fires and even industrial fires and urban fires will break out. Because of the extreme heat, there will be a lot of dry material, right? In forest areas, especially in grasslands or where a lot of dry organic material is available, there will be an easy trigger. That's why Italy, Greece suffered from deadly wildfires. Hawaii in the US, right? One entire town was devastated, burnt entirely. And this wildfire was a result of the massive heat wave conditions, right? So in India as well, we have seen many such fires breaking out. It will happen in industries, in cities as well, in buildings, right, where the temperature is shooting up. There could be a small short circuit. There could be a lot of dry material substances that will easily catch fire. And that's why in summer season, you witness more urban fires and industrial fires. So your firefighting capabilities at the grassroots, at the ground level, should be strong. And in the long term, tackle climate change because climate change, global warming, definitely is playing a role. So these are the basic measures to provide relief, provide the assistance to the people, and save as many lives as possible. It is a preventable disaster. Cold waves are very similar, but the opposite. Is that clear? Cold waves occur in the winter season where the temperature is abnormally low. If heat wave is because of abnormally high temperature, cold wave is the opposite. It's abnormally low temperatures. So here as well, IMD has identified a criteria. The criteria is that minimum temperature, the threshold to even consider a cold wave, should be 10 degrees or less for plains, 0 degrees or less for hilly region. Because in hilly areas, low temperatures are expected, right? The altitude, the humidity levels definitely plays a role. Again, the temperature varies with altitude. So for hilly areas, the threshold is lower, 0 degrees or less. For plains, it is 10 degrees or less. Now, once the threshold is met, then IMD will look at the temperature difference from to what extent the temperature is departing from the normal. If the drop is more than 4.5 to 6.4 degrees compared to normal, if your actual maximum is dropping to more than 4.5 to 6.4 degrees compared to the normal, then it means a cold wave has started. If this drop is more than 6.5 degrees Celsius, then a severe cold wave has started. This is the criteria IMD uses for cold wave alerts. Cold wave also has a huge impact on humans, on the environment, and the economy. See, don't forget, heat waves affect the economy as well because there will be environmental loss. Even animals could suffer from the same condition. If water bodies heat up in heat wave cases, the aquatic life will be killed. There are many cases where fishes have died in large numbers because of warmer waters that are present. The fires which spread, right? It can destroy forests, it can destroy the tree cover, killing many animals and birds. It will harm agriculture as well. High heat is dangerous for agricultural productivity. It will affect the farmers, right? So the economic impact is felt in case of heat waves as well. You'll see the same in cold waves also. Now, in India, the most affected regions from cold wave are primarily located over here. Southern India is not too affected by it. It's all areas above the Tropic of Cancer. From Run of Kutch, from Gujarat to Rajasthan, Punjab, Haryana, J&K, Ladakh, Himachal Pradesh, Uttarakhand, Delhi, UP, Madhya Pradesh, then Bihar, all right, all the way till Northeast India. All these regions, they witness cold wave conditions during the winter months. So when is the peak winter in India? It's from December to January. This is where you witness peak winter. Northern India is notorious for peak winters. Even in arid, dry places like Gujarat and Rajasthan, temperatures drop way below the normal. All right, even in Bihar, in UP. So across this belt, cold waves are a common occurrence, right? Delhi itself witnesses extreme fluctuations. It's a city of extremes, right? In summers, you witness heat waves. In winters, you witness cold waves. So based on this criteria, for plains and hilly regions, IMD will declare that cold wave has started. But again, this departure, the temperature departure, should be recorded for 2 days at two places. That is the same process. So if the drop in actual temperature from normal is more than 4.5 to 6.4, it's just a cold wave. If it is below 6.5, then it's a severe cold wave. Now let's see what happens. What will happen if you're exposed to this devastating cold wave? The peak is obviously in the night, from at least 11 p.m. all the way till 7 a.m., right? And the worst phase is around 3 a.m. to 7 a.m. This is where the maximum drops will be noticed. Now, if you are someone who has to be in the open without protective clothing, without shelter, then you are exposed to the cold wave, right? See, you can be outside, there's no problem. But if you're wearing the right clothing, the idea is to keep up your core body temperature. Because again, your body will not function well if the core body temperature plummets. If you wear warm clothing, the right kind of clothing to protect your body, your temperature levels will be maintained. Nothing will happen. If you have shelter as well, right? If you have a proper house, if you have a proper place to sleep with enough blankets, with enough jackets and thermal clothing, nothing will happen. But those who don't have access to this, those who are exposed completely, right? They are at the biggest risk. What will happen? When your core body temperature plummets, it causes hypothermia. Hypothermia is a fatal condition where your core body temperature has dropped below, way below normal, and your internal functioning gets affected. This could lead to stress on your cardiovascular system, on the internal organs, leading to multi-organ failure and death. It can also cause frostbite if your extremities are exposed directly, your fingers, your toes, your ears, right? These are the extremities of your body where enough blood supply may not be reaching. If this is exposed without any protection, right, you will suffer from frostbite. The blood vessels, they will freeze, they'll burst open inside, and they will simply fall apart. They'll become so brittle, the tips of your fingers and toes, they'll fall apart. This is frostbite. One of the categories who are at the greatest risk are our soldiers, the soldiers of the Indian Army, and even our paramilitary forces, right? They're deployed in very hazardous conditions. Those are deployed in J&K. Have you heard of Siachen Glacier? the world's highest battlefield, the most dangerous battlefield, right? Here temperatures can drop to as low as minus 30, minus 40 degrees. So all across the Himalayan belt, across the borders of China, Nepal, Bhutan, Myanmar, right? Even towards Pakistan in Kashmir. All these borders, they have very, very low temperatures. Cold waves are quite common here. So if our soldiers are not given the right protective gear, eh, and if they have exposure, right, they will suffer from frostbite. In Siachen is a classic example. We have lost many soldiers to hypothermia. Even without any combat or any opening of fire, many Indian soldiers have been killed at Siachen because of hypothermia, despite having the protective clothing and training. Many have suffered from frostbite. They've lost their fingers, entire wrists, or even toes. They have to be amputated because of frostbite. So, this is a deadly condition, right? Other than that, it's again the poor people, the homeless, beggars, and rickshaw pullers who keep working through the night, or even construction workers who might be forced to work in the night, right? All such vulnerable people, again, who are forced out of economic necessity to be in the open, who don't have shelter, who don't have a place to sleep, who don't have blankets or jackets, right, and the protective clothing, they are at the biggest risk. By the time they wake up, their body would have already given up, right? Hypothermia would have set in, leading to cardiovascular stress, causing the death of the person. Many such deaths occur in the country, right, especially in northern parts of India where cold wave can be very, very severe. Apart from that, there is an economic loss, economic damage. Apart from loss of life, extreme cold is dangerous for standing crops, right? Even plants have a life of their own. Same with animals, birds, aquatic life. They all need ideal temperatures to thrive. Abnormal drop in temperature can affect cattle, it can affect poultry, it can affect the fishes, it can affect your standing crops, thereby hitting agriculture. During these peak winters, you also witness deadly smog conditions. This affects transportation and connectivity, and your energy consumption will shoot up. Is that clear? This becomes an economic challenge. Even in a heat wave, when people across the country switch on fans, ACs, and coolers, energy consumption will shoot up, right? And a country like India, which is struggling with energy security, right? It becomes a big challenge. It becomes an economic challenge. We have to increase our import of natural gas, import of coal, produce more electricity. Same happens in winter when people are looking for heating solutions across homes and offices. Heaters will be turned on, right? So electricity consumption will shoot up, which poses a serious economic challenge to maintain energy security. European countries, they suffer from this. Across Europe, there are deadly cold waves that occur in winter, right? The only way they can protect is through heating solutions, and they rely on gas. And who was supplying the gas to Europe? It was Russia. So because of the Russia-Ukraine war, gas supplies were disrupted, which increased the import cost for European countries. And there was a huge economic impact because of that. Because across every home, every office, every building, heating solutions will be turned on, or else people can't survive this devastating cold. So energy consumption shoots up, and managing energy supply, managing your energy imports becomes an economic challenge. The deadly smog conditions will disrupt the operation of your roads, railway lines, and airports. Visibility reduces, right? So there is a direct impact on rail traffic, vehicle movement, etc. So there is a widespread impact, economic impact, and even the rail tracks, right? They expand and compress. So these deadly heat wave, cold wave conditions can affect the integrity of the railway tracks, causing railway accidents. That's also a possibility. So we can't take this lightly. You have to pay attention to these disasters and take appropriate measures. Measures are very simple. Provide early warning. Warn the people, spread the alert, give them enough shelters, give them clothing, advise them to stay indoors, sleep in a proper place with enough heating solutions. Right? These are the basic steps that have to be taken. That's why the Delhi government, for example, right, it has built many shelter places where rickshaw pullers, homeless people can come and sleep inside, because there have been cases in the past where people who were sleeping on the outside, on footpaths, on roads, they they were dead by the morning because of hypothermia. Right? It's a very unfortunate situation. So to prevent this, Delhi government has built some shelters, and basic clothing, blankets, bedding is given so people can sleep in a warm place without suffering the impact of cold wave. So both heat wave and cold wave are actually dangerous disasters, and the worst part is it mainly affects the lower sections of the society. So given the disproportionate impact on the poor people, governments have to pay more attention in disaster management. These are preventable deaths. All these deaths occurring due to heat wave and cold wave can be prevented. It just requires better planning, better preparedness, and better response when the alert has started. Is that clear? So this completes my discussion on heat wave and cold wave. So let's complete the other topics after the break. Let's take our tea break. I think it's 40 minutes, right? Let's come back at 5:40. 5 p.m. to 5:40 p.m. will be the tea break. So we still have few minutes to go. I can take some questions and doubts, and then let's proceed with the break. Let's see what questions have come up. Sanchit is asking about PYQs. Don't worry, we'll do the PYQs. I want to do it at the end. Since it's a small subject, doesn't make sense to take up questions after every topic or every chapter. We'll wrap it up next week. Next Saturday, we'll wrap up the syllabus, right? We'll let you know the timings as well. So at the end, I will discuss all the questions. We'll look at some questions. I'll discuss few. Rest I'll give it to you as assignment. So I will take up PYQs. It's very important. Don't worry, it will be done at the end. Vivek is asking comparison on both heat wave and cold wave. We already discussed it. What's there to compare again? Right? Just go through the points. It's already there in the slides. And I've explained both of them in detail. And UPSC will not ask you to compare heat wave and cold wave. It's like apples and oranges, right? They are opposite ends of it. So understand the topics separately. Even if you get a mains question, right? UPSC will not ask you to compare the two. Comparison comes in only when one is better than the other, right? That's not the case here. Both are disasters, both are equally dangerous and hazardous. So understand what causes the condition, how we identify them, what is the impact, and what measures can we take in disaster management. That's it. These 4 5 points, you're done with the topic. Anything else? Chituri is asking, sir, is there any technology which will transform smog to rain? No. Smog, how can smog be converted to rain? No, there's no such technology available. All right. So, guys, these were the questions. So, let's take the break. 40 minutes. We'll come back at 5:40. Now, after the break, we'll discuss geophysical hazards, earthquake, tsunami. Okay. Then we'll discuss biological hazard. We'll discuss epidemics and pandemics. We'll also try to cover forest fires. So that should be more than enough as far as natural hazards are concerned. I think for today, this should be enough for the last class today. Then next week, next Saturday, we'll continue. We'll discuss the man-made disasters and the global framework and India's architecture. That's it. We have left with only few topics. So take your 40 minutes break. I'll see you back at 5:40.